I am very happy that almost 100 people came today, but I want to see them after 2 weeks, the same number, which means if you start, go ahead and finish it. Now I want to say, I am very happy that Elior agreed to give this class. He is a student in material sciences, and I am very pleased that he is willing to take the challenge, and I wish him all the best. Now, I want to tell you another word about the importance of Matlab for you as students. If you really become skillful in Matlab, not like, just coming, listen and go, but you are doing homework and try to do something, then it will help you a lot and save you tons of time in, experiment, exercises, and so on and so forth. And it will make you more professional. So this is the goal. Well, I think that I spoke enough. Elior, it's your stage. Wish you luck.
Okay, thank you. So as Ruben said, my name is Elior Segev, and I'm gonna teach you Matlab today and very basic things in Matlab that you need in every lab. Now, we opened this course because there was a problem that nobody actually taught what we need in the lab work, and that's what we're going to do today. Now, because so many people came, I won't allow questions during the lecture. Okay, if we can call it a lecture in class, let's say. But what we're going to do at the end, will take 30 minutes just for questions. So every class is going to be approximately 1 hour and then 30 minutes for questions. Now, I highly recommend you to open what I do in half of the screen and then your Matlab in the other half of the screen. I'll show you now. So can you see my screen? Hopefully, yes. Can someone tell me whether you see the screen or not? You can unmute yourself, it's not a problem, I think. Probably in the chat, yes, perfect. So I open Matlab here. Okay. And I highly recommend you again to do it with me. You cannot unmute yourself, wait. Yes, now I think that you can, right?
Yeah, thank you.
Yes, perfect. Okay. So that's what you see when you open Matlab, okay? Now here, you can see my cursor. It's here, okay? Wait, I'll do it like that maybe. Spotlight. Okay, I think now it's better. So this is a command window, and that's where we write all the comments. Now, I'll start with something which is very simple. Matlab is a great calculator, okay? So first thing I'm gonna do is to write 3 times 5, okay? And I press enter. As you can see, I get the results, which is 15. Now, a command is an instruction to the computer to do something. And we'll see later on how we use it. Instead of just writing the number, I can assign the 15 into a variable. So I can write m equals 3 times fix, for example, and I press enter. As you can see now, Matlab writes to me that m equals 18. Here on the right side, where the workspace is, you can see 2 things. If I assign the number that I wrote or the calculation that I've done into a variable, it will be stored in the variable. So m now equals 18. Every time I will write m, it will take it as 18. If I won't write anything, it will put it in answer, okay? As in every regular calculator. Now, another thing that I want to show you, I can write, for example, m equals m plus 1. Now, what I get when I press enter is that m equals now 19. Why? Because every time Matlab does all the calculation, all the right side of the equation at once, and then it assigns it to the variable that I chose. So now it will take, for example, 18 plus 1 is 19, and then it will store it into m. M now equals 19, as you can see, and it does not remember that 18 that was before. Now m equals 19. I can write, for example, now y equals m divided by 2. Now look what I add at the end. In the end now, I write this semicolon, okay? This semicolon, wait, now, when I write y equals m divided by 2 with a semicolon, Matlab doesn't print the result as we saw it before. I can see here in the workspace that y equals now 9.5, but it does not print it. It's very important because when we write many commands at once, we don't want Matlab to print every time the results. It's first of all uncomfortable, and second takes more time. So pay attention to that. That's what we're going to write from now on. If you press on the upper arrow, you can go up to stuff that you've done before. Okay, so I can go back to m equals m plus 1 and press enter again. Now m will be 20. Again, why? Because it's not an all command. It's a new one. M was 19, it adds 1, and then it stores it back in m. Okay? Good. Now we're going to talk a bit about variables. Variables are a way of Matlab to store the data. Okay? It's very comfortable to work with. Now, how does it work? I write, as you saw before, oh, yeah, I was muted for a second.
Elior, I couldn't hear you.
Okay, yeah.
Oh, now it's okay.
Okay, so I'll go back. Variables are the way of Matlab to store the data in the workspace, okay? Notice that everything that we write on the left side of the equal sign is a variable, which means that it doesn't matter how I call to the variable. I can write there whatever I want. On the right side of the equal sign is the calculation. So now Matlab takes this 3 times 6 and store it into m. Now, it's very important when we work in Matlab, and we'll see it later on also, that we want to give variables which has a meaning. Why? Because when we write a long code and we need that the data will make sense, or the workspace will make sense every time I look at it, it's very easy if I choose name that tells me something. For example, I can say now A equals 5, B equals 6, and now when I want to calculate the average, I won't write X equals A plus B divided by 2. I won't name it like that. I will name it, for example, AVG, because that's average. For me now, it makes more sense. When I look at average, I know what this 5.5 means. It's the average of A and B. Okay, now I'm going to send you in the chat a file. I wrote for you, I think it's pretty comfortable cheat sheet. Okay, I sent it in the chat. Now there you have many Matlab commands. I'll show you it for a second. I'll mute my phone, sorry. Here. So here you have the cheat sheet that I wrote for you. Now you have all the elementary arithmetics like plus, minus, multiplication, power, everything you need. Okay, everything, not everything that I say, but many examples and many things that we'll see will be here. So you can just check it. I think it's pretty comfortable. So let's keep with Matlab. Okay. Now I will write now CLC, which will erase everything I see. So I can start again. Okay. Now in Matlab, we have built-in functions. Okay. What are the built-in functions? For example, sine, cosine, square root, everything. Those are all the built-in functions. So I can write now. I'll clear all I have here in workspace. Okay, you just type clear all, and then you clear everything. I can write now, for example, x equals 9. Okay, now x equals 9. And I write for you all the syntax for the built-in functions. A syntax is the structure of the command. So I can write the variable name equals the function name. And then inside the rounded bracket, I can write the input. Okay. So for example, I can write y equals squared root. This is the function name for squared root, and x. When I press enter, I can see that y equals 3. Okay. The sine, for example, function, I can write now y equals sine of pi. I press enter. Okay, we can see two things. First of all, pi is also a built-in function. It doesn't get any input, and it equals, if I write enter, 3.1416 and so on. It has many numbers. It's not exactly pi. I don't know by heart how many numbers it has in Matlab, but it has a lot. But we can see that it's not exactly pi, and we'll see it later on how we use pi exactly. And the second thing is because pi is not exactly the real pi, just approximation, we get that it's not equals exactly 0. It's very close to 0, but it's not 0. And this is a disadvantage, but it's not that bad because we'll see later that we can use pi exactly. But now it's not very important. You have many more functions. For example, I can write y equals abs of minus 5, and it equals 5. And remember that it doesn't matter how I call to the variable, okay? If it's y, it can be whatever you want. It doesn't really matter. And there are many functions who get 2 inputs or 3 inputs, 10 inputs, doesn't matter, many inputs, and lots of outputs. And we'll see later how we use it, but for now it's enough. Okay, now we saw until now just variables which are scalars. For example, this y, which equals 5. We can create vectors. How we create a vector? We write x, for example, that's what I use for vectors. And in squared bracket, I write the numbers that I want. For example, 1, 2, 3, 4, 5, and so on, as long as I want. When I write enter, you can see that x is now a row vector, okay? Now, I can make it a column vector. How? I can write x equals, in squared bracket, I put semicolon between the numbers. For example, 1, 2, 3, 4, and 5. When I do that, it puts every number in a new row. So when I press enter, I can get it as column vector. okay? Now, I will use mostly uppercases for vectors and lower cases for variables. Okay, that's how I wrote a cheat sheet. Perfect. I can write the same way a matrix. X equals, if you know how to write a matrix, try it for a second. It's the same sense of writing row vectors and column vectors. I will write everything that I want in the same row with a comma or with a space. And when I want to move to the second row, I will use semicolon. For example, 1, 2, semicolon, 3, 4. Now I get X as a matrix. Okay, good. Is it clear so far?
Yes.
Okay.
Yes.
Good. So now, many times I want to make, and we'll see soon why it's very useful. I want to make vectors which are linearly spaced. Okay. How do I do that? I write X equals 1, and then I use those, I forgot the name, I'm sorry. How do you call to this, those 2 dots? I don't remember.
Colon.
Colon, okay. So 1, colon, and then 10. If I press enter, you can see the result. I get a row vector of 1 to 10, okay? Linearly spaced by 1. So 1, 2, 3 until 10. If I want to make it a linear space with half, for example, I can write 1, X equals 1, 0.5, and then 10. I'll get now all the numbers from 1 to 10 with space of 1.5. So I get 1, 1.5, 2, 2.5, and so on. Okay? Now, if I want to make something more complicated, I can use the function Linspace. Now, what I write in Linspace? In Linspace, I write the first number that I want. Then comma, last number. And then afterwards, I write the n. The n stands for how many numbers I want in this vector. For example, X equals linspace 1 to 10 with 20 numbers in between, including 1 and 10. So when I press enter, I get a row vector with 20 numbers from 1 to 10. Okay, we'll use it soon. So 3 comments, okay. The first one is if I want to change it from raw vector to column vector, I can use it transpose, as in linear algebra. I can write, for example, y equals x, and then I use this quotation mark, small one, okay? When I press enter, I get it from raw vector to column vector. That's first. Second, I can create a vector of functions. For example, I can write x equals now square root of 9, comma, abs of -5, the absolute value. Press enter and it calculates it. Again, it calculates each one separately and then it put it into X. Okay, good. Now we're gonna go to experiment number 1. Now, I made you experiment that I've done before in the physics department. The first one is not the most complicated one, but you'll see why it's useful. So I'm gonna clear all the workspace. I'm gonna clear the command window. And now I'm going to tell you about the experiment. Just a second. Now that's the experiment. I have a ball here. I really try to make it like 3D ball, but I'm not a great painter. So it falls down from 10 meters to 0, okay? And we hopefully all know, and if not, it's not very important, that the equation of motion is x equals x0 plus v0t plus half a t squared. Now, I know where I started. I started at 10 meters. I know that I dropped it with 0 velocity, but I don't know what is the acceleration, okay? And it's not just g, it's a bit different. And we'll see now how we're going to calculate it. So we put it in a machine, or we use a sensor, and the sensor gave us the place of the ball at each time and the time. So we got it here in experiment number 1. I'll open it in Excel. So this is how we got it. We got a time and the displacement. So at time 0, we started at almost 10, very close to 10, and then all the way to 0 with after 1 second. Okay. And now we want to analyze it in Matlab. So what we're going to do? First, we want to import experiment number 1 to Matlab. So I open Matlab, I go to Home, okay? And then I go to import data. I press on it. I go to the desktop and I choose experiment number 1. Okay, please try to do it with me. Okay, I will do it slowly. I'll give you time to open it and to do that. It's very important that you do it with me because it will give you some more intuition about how we work. So I choose your experiment number 1 and I press open. Now, this is the window which opens. Here I have all the import informations and we're going to go through it now. So the first thing that we have is here the table, experiment 1, time displacement. As you can see, Matlab knows that the first row is the name, okay? So it's gonna choose it for the variable name, as we saw before. We can choose here, very intuitively, whatever you want to import. So I can choose everything, or I can leave some things out if I want, as you like. So this is about that here. Now, here in the output type, I can choose whether I want Matlab to import it as a table, as a column vector, as a matrix, string array and cell array, leave it aside for now. It's not very important. We want to import it as column vectors. And that's what we're going to choose most of the time, because it's much more easy to work with the time and the displacement separately, because it's not the same. So that's what we're going to choose for now, okay? That one we'll see also later. We'll do this import many times, so we'll see later why we need it. And then I press on import selected data. I can quit it, and then you see here in the workspace that I have 2 column vectors. I can double click on it, and then you can see the results. That the time, it started from 0 to 1, and the displacement goes from 10 to 0. Okay. So first of all, when we do this kind of experiment, we want to see the result, want to see what we got. So the first thing I recommend you is to do a plot. A plot is a very simple graph in Matlab. How we do plots. So to do a graph, I write plot x data here, comma, y data. Okay, so try to do it all. And then I write here the time, that's the x data that I have. And then the y data is the displacement. So this is the result that we get. Now, this data makes sense. Wait, there are some comments. Okay, this data makes sense. Why? Because we expected to get a parabola, okay, which goes from 10 to 0. So we're happy about this result. I know we don't have the X labels and the Y labels, and we don't have everything we want in a graph, and it's okay, we'll see it. But first we want to see the result. Now the second thing we want to do is to make a fit. We want to see how good the data that we get fit to the theory. So I quit it, and then I go to apps. That's why I ask you all to download all these add-ons. I go to apps and I click on curve fitting. Okay, so you click on that. And this is what opens. Okay, now what we do here first, on the left side, we choose the data that we want to make the fit. We choose the data for the fit. For example, the X data is going to be the time. And the Y data is going to be the displacement. Okay, and we can start to see something. Now, in this area here, you see the fitting function. For example, the Matlab chose automatically polynomial, you see, with degree of 1. We know that it's supposed to be polynomial, but with degree of 2. So we can change it to 2. Here, the blue line, you can see that's the fitting curve that Matlab chose. And all those dots are the data that we collected. Okay? Now, if you press on the polynomial, you can see many types of fitting curves that we can do. For example, I can try to do it exponential if we have exponential data. Okay? You can do it Gaussian, anything you want, sum of signs. Okay, we have many options. Now, we know that data that we have now is supposed to be polynomial with degree of 2. So that's what we get. Here in the results area, we can see that Matlab chose linear model poly 2. Okay, that's what we chose. That's the type of the function. Here we can see the coefficients and what they mean. P1 is a coefficient for x squared. P2 is a coefficient of x, and P3 is a coefficient for x to the power of 0, okay, to 1. Now, here we see underneath the goodness of fit. So we can see the r squared is 1, which means that it makes sense. Now we want to save this data, okay? So what do? We go to fit and save to workspace. I press here and I can save the fit. Here you can see save fit to Matlab object named, and then I can choose the variable name. Because it's a fit, I choose it as F. Save goodness of fit. Many times I just write GOF, okay, goodness of fit. And the output we don't need, it's something that we never use. And I press OK. I can quit it. And now I can see the result. I can click F, write F, and then press on Enter. We can see the fit that we got. Okay, here we can see the coefficient. That's what tells me what is the acceleration. It's -10. I can write the goodness of fit. I press Enter. And then I can see that the R squared is 1, okay? Is it clear so far, or was it too fast?
I think it's quite clear.
Okay, perfect.
What is the R square?
I'll give you to ask in really like 5 minutes, and then it will be enough for today. Okay, it's already lots of information. Okay, let me check it. Okay, so we did that, and now we want to plot it, okay? We want to plot everything together. So what we're gonna do is we're gonna go to home and press a new script. Now, a script in Matlab, oh, sorry, before that, we want to save it. We never forget to save after we do the fit and import the information. It will be super awful if you do lots of work and then you don't save it. So I press here, save workspace, and I choose where I want to save it. For example, I go to desktop, new folder, experiment 1, and I name it X1. Okay, good. We save the workspace, so we have the fit, we get the goodness of fit, displacement, and time. We have everything. Now we go to new script, okay? We want to plot it, we want to make it nice, and we want to save it. If like tomorrow or the day after, we want to change the plot, we want to change the names, we want to change many things, we don't want to do it all over again. So we save it as a Matlab file. You press a new script, and then you have it as untitled, okay? I go to the same folder, okay, and it's important. I save it in the same folder where I saved the workspace, okay? You can give it a name as you like. Experiment number 1. Pay attention that here it's .m, okay, so it's not a problem. So I save it both in the same place. And the first thing that I write is load. And then you should go to the folder and to write the name of the file. So here I go to experiment 1. The name of the file is x1.mat. I write here, load x1.mat. Okay. I can see that it works. Unable to read, not such a file or directory. I didn't save it in the same place. I'll check it later and I'll write for you why it didn't work now. Yeah, I don't know, maybe I didn't save it in the same place, or maybe there's a different problem. Okay, it doesn't really matter for now. So we will load it. I'll write for you later. I'll check it why it didn't work. So what we're going to do now is the plot. We want to plot 2 things. To plot many things, first we write figure, and then we write hold on. The hold on, this one is very important. So we will see different plots on the same figure. And you'll see now what I'm talking about. First thing we want to plot, the data that we got, which is the time, comma, the displacement. That's first thing. The second thing that I want to plot is the fit that I've done. So I write plot and then just F. It's enough, okay? Now I'm gonna add things that will make the plot nicer. For example, the X label. So I can write X label. And then in those quotation mark, I write whatever I want inside. For example, I can write time, and in square bracket, I can write seconds. Same thing for the Y label. In quotation mark, I write displacement, and then meters, okay? I can write, for example, grid on. You'll see now what it does. You should press here, add to path, okay? It won't change the folder of the file that you made. And here you can see it, okay? Now in this case, wait, I'll put it here. Yes. So in this case, okay, you don't see both of the curves because they collide actually. It's the same curve. So I can change it here in the plot. I can write in quotation mark this little o. Now what it's gonna do, it's gonna change the plot type. You can see it here. Okay, now I got a different plot where all the data is stored in those little circles, and the fitting curve is in red, and it's continuous. Okay, now we're gonna see soon how you change everything and how you control everything in a super comfortable way. Okay, so don't worry about that. I can write now grid on and grid minor. That's my favorite preferences for plots. Okay, I can write, for example, the title. Now, I have on my computer, and that's what I wrote for you, I have a list of all the things that I want to add to the plots. Okay, so here I can write displacement over time. Okay, I write everything, I press play, and then I get it again. Okay, now in the beginning, most of the time I write here close all and clear all. Okay, so all the plots that I've done so far, when I write close all, it closes everything except for the Matlab. Okay, see? And when I write clear all, it clears everything I have in the workspace. Don't worry, because we load it again. Okay, after we press clear all, we press play, it loads everything again. Why? Because I wrote here, load x1 Matlab. Okay, so what we've seen so far is pretty much a lot. Okay, we saw how we use variables in Matlab, scalars, and vectors. We saw how you plot things in Matlab, and we saw how you do simple fitting curves in Matlab. So I think that that's all for today. Okay, if you have questions, I'm here for like 30 minutes or so, and you can ask me anything you want, which is of course related to Matlab. Okay.
Elior, could you please show how you integrated the Excel into your data, like data in the Matlab? What did you click? I just missed that 2 seconds. I'm sorry.
To do integration to the graph, you mean?
No. I mean, how did you integrate your data from the Excel into the Matlab?
Oh,
import data. Yeah. Michael, you're right. Yeah, thank you.
You go to home and then import data.
Ah, okay, that's perfect.
So,
thank you. And it's imported as matrix. No, sorry, vectors, right?
You can import it as you like.
Oh, okay.
I recommend you not to import it as a matrix because it's really uncomfortable. I mean, your data is not a matrix, so it doesn't make any sense to import it as a matrix.
Yeah.
But if I press on import data and I open this window again, here in the output type, I can choose as I want it. So for example, here I choose it as column vectors. which means that the time and the displacement are going to be two different arrays.
Mm-hmm.
Okay, I'll have time vector and displacement vector.
No problem.
Okay.
Okay.
Good.
Great.
Why did you put the hold on?
I put the hold on. I'll show you. Sorry, maybe I'll just write it to myself to show it next time. I put the hold on because I want them both on the same figure. For example, if I won't write it and I press run, I will get two different figures.
Okay.
I'll get the first one, you see it slowly. I'll get the first one with all the data. And then when I press another step, it will ruin the plot that I had before and I'll see just the last one. If I write the hold on, it won't ruin everything I've done so far, okay? It will put them both together on the same plot.
So if you have the hold on, it's going to be a combination.
Yes. Okay. And then I can put as many graphs as I want.